Thanks everyone for joining me. I know it's been a long day. It's last session of the day, and we do have the attendee party coming up shortly. So I will try and make this as long and as painful as possible. I am the last session that you are going to be sitting through for today, so I will draw this out as much as I can. For those of you I haven't had the pleasure of meeting already, my name is Aaron Powell. I work for Microsoft as part of the the cloud advocacy team. I keep saying developer advocacy, but it's been cloud advocacy for quite a while now, and I don't know why I've fallen back into old habits. If you want to reach out to me after the session or anything like that, you'll find my contact details up there on the screen. I've also got some links that will cover off the kind of stuff that I'm talking about today on my blog, and I've got some more links towards the end. But I said, we're going to get through this because you're here to learn about GraphQL, not about me. So that's the topic of today. We are going to be talking about GraphQL. And I first came across GraphQL in 2015. I was at a user group, and it was the SydJS. I'm from Sydney. It was at SydJS, and I was talking about this new thing that Facebook had just released called GraphQL. And my immediate reaction was, it kind of looks like OData for JavaScript hipster developers. Because I'm from a Microsoft, a .NET background, so I've shout out to the people that actually are familiar enough with OData to have ever used it in anger in any form. But yes, that was my initial reaction, and here we are a number of years later, and we can greatly say that that particular comment of mine did not age very well. Yes, it is still in my Twitter timeline. It has been put in blog posts. It's in talks that are published on YouTube and all that kind of stuff. So I was very much a GraphQL skeptic for a long time. But here I am. I am actually going to be talking about JavaScript and not trying to convince you any other way that it is a worthwhile bit of technology to look at. But what is GraphQL? So just hands up in the room. Who has looked at GraphQL before coming to this session today? Cool, I see a couple of hands there. Well, hopefully what I can show you is still going to give you something new to take away. But for those of you that aren't familiar with GraphQL, GraphQL is, well, it's essentially a query language for APIs. That's the way they describe themselves. And it was created by Facebook to solve Facebook scale problems. Now, I like to make that emphasis as part of the talks that I give about GraphQL because it's important to understand that GraphQL isn't going to be right for every project that you build. Yes, there are a lot of use cases that GraphQL will be suited for, but there are a lot of use cases that it's not going to be suited for. So use it as an opportunity to learn something that can be a new tool in your toolbox, but not the only tool in your toolbox when it comes to building APIs. Now, GraphQL is kind of an opposite direction to the way that we would design an API compared to REST. GraphQL very much puts the onus of responsibility to the client in that they have a lot more of the power about what data that they want and how they're going to get that. The server defines the data that's still available. Like the server still has to present a data schema that a GraphQL client can work with, but the client is the one that then is able to select out of that what they want to achieve and what data that they need. Now, the reason this is this can be advantageous is that it gives you an ability to avoid a common problem with REST, and that is overfetching of data. Let's say that you have a REST endpoint where it will return like 15 fields for a single object model, but for this display, you really only need 2 or 3. Now, sure, us here in Australia with our super fast broadband internet and our 5G access, we can pull that down in no time. But think about people that have poor internet connections. Someone that maybe doesn't live in Melbourne. They're like 2 kilometres outside of the CBD. Or someone that their only access is via a mobile device in maybe a developing nation, like Africa or South America or somewhere like that. You don't want to be sending them megabytes worth of data payloads if they don't need it, because you really only needed kilobytes in that message. So that's something that GraphQL can address in a slightly easier design than you can with REST. It also has its own problems that GraphQL can introduce. I'll show it off in a demo a little bit, but GraphQL is a great way to create your own denial of service vectors against your backends. We can create a GraphQL query where we're going to build a trivia application. So a trivia app has games in it. Games have players. Players have games that have players that have games that have players that have games. And it's a graph. It nests all the way down, and the server will go, that's fine. It's a perfectly valid query. I will attempt to execute that n number of times against your database, and all of a sudden, you have just deadlocked your backend and you've fallen over and it's like, yay, I've DOSed myself with my own service. Isn't that amazing? So yes, be mindful that there are things that GraphQL does not do particularly well. Also show you how you can solve some of those, or I can tell you some ways to solve some of those problems. But with GraphQL, we have two core components. We're going to have a server, and that's where our data contracts are exposed from, and that's what's going to be handling the things that we're doing. This is TypeScript with GraphQL, so we're going to be using the Apollo GraphQL open source project. I'm going to show that with Azure Functions, but Apollo has bindings for pretty much every server runtime you could want within Node. Express, Koa, things like that if you want to run them as traditional servers. Azure Functions, naturally, because that's what I'm going to be demoing today, AWS Lambda, Cloud Run, Cloudflare Workers, kind of you name it, they probably have a hosting model for that. If you're from like a .NET background, I'd recommend checking out Hot Chocolate. It's a very obscure name for a GraphQL library, but it's in my experience been the best .NET GraphQL server implementation that I've come across. And then there's pretty much every single language under the sun has an implementation of GraphQL. I'm a .NET and JavaScript person, so those are the two areas I play in. But then we're going to need some kind of a client application that's going to talk to that. Again, we're going to build a client-side application that runs in the browser. I'm going to use React for the demo today because that's the client-side framework of choice for me for this week. Next week will be something different because something new will come up, and I'm going to move on to that because I'm if I'm doing front-end web, I've got to chase something new every single week. That's the only way you can build applications these days. But for that, I'm also going to use some tools from Apollo. They've got some great bindings into React, but also into other JavaScript frameworks like Angular and Vue and Svelte and et cetera, et cetera. All right, but today's talk is about type safety with GraphQL. So what's that all about? Well, GraphQL is a type-based way of defining a data schema. With other forms of API design, you might design the API first and then come back to the concept of adding sort of types over it, like OpenAPI. You do that often after the fact. It's a secondary consideration to the API that you've built. GraphQL, you have to build a type system for your server to implement. So we have a type system in GraphQL. We're going to build something with TypeScript, which is type-safe JavaScript, so it's got a type system. But what we end up with is two independent type models within inside of our application. Here's a snippet from the application we're going to be building. So on the left-hand side, I'm like, which side is it? I'm still not used to the fact that I'm in front of the screen and I'm not just like a flipped image going out over like a YouTube video. But on the left-hand side is a GraphQL schema, and if we see, it kind of looks JavaScript-esque. Like you can see that there's stuff in there that I can look at that and understand that there's a type system in that, and it kind of looks like the types we might have in TypeScript. And then we have some TypeScript on the side, but I want those types to be coming across. I want to know what a question and a player are. I want the enums and things like that, because they're probably going to be useful for me in the application I'm creating. So how can we go about doing that? Well, let's jump over to VS Code and actually do some demos, because I think that's enough PowerPoint. It's end of day. You're not here for just looking at PowerPoint. So we'll jump over to the start of my demos. And let's find the right VS Code. I've got like 7 VS Code instances open, so this is going to be bouncing around all over the place. All right, so this is, I'll put the link up to this Git repo where all the code is for today's sample, so if anyone wants to have a play. It's actually part of, I gave a 2-day workshop at the start of this week on doing type-safe GraphQL. So I'm doing the 2-day workshop in 49 minutes. So be prepared for it to go faster. But yes, the whole workshop code is up online, and there is a longer form video that walks through it than we're going to have time for today. But let's get started. So I've scaffolded out my project here, and I'm going to create a new Azure function in here that we're going to put GraphQL into. So do func new, and give that a second. We're going to select a HTTP trigger, and we're going to call that GraphQL. All right, and we'll go to index in GraphQL. Close these down. Let's just have a bit more space on screen. There we go. All right, so scaffold out a basic Azure function. That's not really what we're going to need. We're going to need to bring in some Azure, we're going to need to bring in the Apollo dependencies. So I would actually need the terminal back. So So we do npm install -d, because I want it saved as a local dependency. Oh, you don't need to push -d, and do that out of habit. By default, it will save it as a dependency in the dependencies section of your package.json. And then we'll do Apollo, server, Azure functions, and we'll need the GraphQL package as well. Because it'll take a couple of minutes for that to install, I've already pre-installed them. We'll import those. So we'll do we'll do Apollo server and grab GQL, which is a template literal function that will allow us to generate, to write a GraphQL schema. And we'll import that from Apollo Azure functions. And we are then going to create some type definitions. So we'll create a GraphQL schema, type type defs equals GQL and backticks to start our little template literal. And we'll create a type called query, because this is going to be our read operation. So we're going to query against our GraphQL server. It uses conventions to know that a query is going to be like a read operation. To change data in GraphQL, we use a mutation. It's not, it doesn't distinguish between create, update, and delete. It is always a mutation, because a mutation could be tackling multiple operations at the same time. You're mutating, changing your backend. Doesn't matter whether it's which of the three aspects of a mutation that could be. We'll just call this hello, and we'll say that that's going to be a string, and the bang or the exclamation point means that it's non-nullable. We'll create a resolvers that will handle this. So this will just be a JavaScript object with query, and they'll say hello, and this can return hello NDC Melbourne. Melbourne, there we go. Now, we will create the Azure function, we'll create the Apollo server and export that from Azure functions. So we'll export default, oops, not deflate, default. Actually, so I've got to create a server. Const server is a new Apollo server, and we'll pass it the type definitions and the resolvers. So we'll pass it our GraphQL schema and the things that are going to react to handle the GraphQL schema executions. And then we'll export default server.start. And with Azure Functions, we do need to do one other thing, which is change just how it returns. This is just a nuance of Azure Functions. It returns, instead of an output variable in Azure Functions, it will return as the result of executing that function. So I've got to change line 16 down here to $return. Like I said, that's just a nuance of Azure Functions and the way output bindings work. I'm not going to get overly deep into Azure Functions, but if you want to learn more about Azure Functions, I'm wearing a t-shirt about that, so I'm happy to help you afterwards, after this session. Okay, so that should be all up and running. Let's pop our terminal and do npm start. Give that a second. So this is compiling my TypeScript down into plain old JavaScript. It's going to start the Azure Function local development environment. And with a bit of luck, that's going to pop up, and everything's going to crash, and I'm going to cry massively because I now need to work out what that stack trace means. Isn't live coding awesome, folks? It was going so well, and it's not like I've practiced this before or anything like that. Okay, so let me just go back to my notes. There are readmes in every section of this workshop code base that you can go back to, and that's precisely what I'm going to be doing right now. It was server.createHandler, my bad. Okay, now let's try and restart. Whew. Oh, no, I've just doomed myself by saying that's going to work properly. Right. Here we go. Second time's a charm. Excellent, it looks like it's worked. Stop logging out. I want to click on that link. That's going to open in a browser somewhere. Here we go. Let's just zoom this in a few ticks. With GraphQL, or at least with Apollo, they have Apollo Studio, which is a way that we can kind of play with and query GraphQL servers. Similar idea to like Postman and Insomniac and stuff like that for REST. There are tools, extensions for VS Code. If you came to my talk about VS Code yesterday, I talked about one of those in particular. But this is obviously GraphQL specific. Okay, it's up and running, and well, it was up and running, it's just reloaded. Got it. We can see on the sidebar here, we can see our GraphQL schema. We'll see that there is a field that I can query called hello. It's going to return me a non-null string. Let's add that to a query operation that we're going to execute in the middle. Hit Control Enter, and there we go. We've got a response back from our server. Excellent. First demo done. Only like 6 more to go for this talk. But that's probably the most basic way you could write a GraphQL server. We've got a very simple GraphQL query, GraphQL schema that has a single field query that returns me a string. I've created a resolver that then just returns a static message out of that. Excellent. Let's stop that down and jump to my next VS Code window that I've got open. Not that one. That was the one I was already in. Here we go. Okay, so jump forward, and now, well, we've embedded everything within inside of like a single TypeScript file, and that's probably fine for what we've written right now, but it's not going to scale well. It's also going to be very difficult for us to understand what the types are if, like they're hidden within inside of TypeScript files. They're not GraphQL files that we could maybe inspect with some other tools. So let's go about extracting this out to another location. So I've gone ahead and installed a couple of additional packages to my project here from, oops, not Control Z, V. They are from a open source project called GraphQL Tools, where we're going to load a schema from a file on disk into our GraphQL server and combine it with the resolvers so that the server is capable of handling that. Again, I've pre-installed these just to speed up time. And to save me messing up my code again, I'm just going to go to the README and copy and paste a snippet from before. All right, so it's this one all the way down to here. Come back, paste that in. All right, so I need to create a new file called schema.graphql because that's what I'm trying to load here. And we'll put that within inside of our GraphQL folder here. A new file, schema.graphql. And we'll just do our type query, and I will say hello as a string. I think that's still what it is. Yep, hello as a string. Obviously, the message is going to be a little bit different this time because I've put it in a, because it's a new project, but npm start. So everything should work just the same, but all I've done is I've moved the file out separately. So we're starting to modularize our application, I guess, a little bit, make it easier to maybe find things that are in different locations. But let's see, starting up. Almost some verbose warnings in there that I'm just going to ignore and cross my fingers and hope that the demo works successfully. Excellent, there we go. Let's open that one into the browser. Oh, it's on an entirely different port this time. All good. So execute this in our Apollo Studio. And woohoo, hello from our GraphQL backend. So didn't really change anything, haven't really done anything major here, but now we can go ahead and start building out a much more complex GraphQL schema. So let's start building out what we kind of had in the slide deck there. So we'll do an enum, and we'll call that game state, because we're going to build a trivia game, waiting for players. We're going to have another state which is started, and then completed. And we'll build out some more types because we can model all of the types that our backend wants to expose. It doesn't have to be directly the types that are in your database, but these are the types that you want your clients to be able to work with. It's then the server will work out how to turn them into SQL queries or NoSQL queries or whatever your backend stores might be. So we'll have a type called player, which is going to have an ID, which is a special, so GraphQL has a number of built-in types, strings, ints, floats, booleans, and the ID as built-in scalar types. ID is kind of a unspecified type. It can represent anything in your backend. It just has to be serializable as a string, generally used for primary key or like primary identifiers of objects. So you would use them from a caching standpoint. We'll have a name, which is going to be a string on the player, and the player will have games, which is going to be a list of game. And this is a list of non-null objects. So this is a non-null list, so you always get a list of 0 or 1 or more, and all the items within inside of that are not going to be null either. So we're kind of like really doing everything we can to eliminate the possibility of getting nulls back. We're going to have another type, which is question, and a question will have an ID, which is ID as well. It'll have the question as a string. We'll have some answers, which will be a non-nullable string list, and then we will have the correct answer, which can also be a non-nullable string. And we'll have a game type, game. And this will have, obviously, an ID. It will have a players array, players list, player. It will have questions. Question. We need another type for answers. We'll call that answer, and game state. So we'll do state, that will be a game state. So we can refer back to that enum that we created at the start, and we'll do a type of answer, type, answer, and this can just have, say, string, it can have the player ID, and that could be the game ID, question ID, and, got my spaces in the wrong place and it's not liking that from the colorization. And then lastly, we'll have the answer, which is whatever the player has actually submitted to our trivia game. All right. Lastly, let's have, say, our query type, which is then going to have game, which will take an ID, so we can get back an individual game. So if you want to pass a parameter to a query or a mutation in GraphQL, you just kind of make it look like a method. So this is going to take a single parameter called ID. We have to then type that to whatever we want it to be, and then it's going to have a return. Let's make this return a nullable game, because if we don't have a game, we'll return null. If we do have a game, we'll obviously return that. And then we'll just have a way that we can get back all games. And done. Okay. Now, if we were to, let's restart our server. I don't have a file system watch running, so I just got to hit restart. Give that a moment. Fingers crossed. Okay, there we go. TypeScript's compiling. It's starting up our server. And, we've got another error. Gosh, it really is getting late in the day, isn't it? Okay, let's have a look. So, we're starting to already break down in the type system. If we have a look at that error message that it says there, let me just highlight that so it's a bit clearer where I'm going to be pointing to. So, what it's saying is that the query hello is defined as a resolver, but it's no longer in our schema. Well, so that's because I updated my schema, right? And I removed the little test schema that we had, but I didn't go back and update the resolvers. I didn't realize that I might not have realized I needed to go back and do that because maybe I'm working on the schema design and someone else is working on the back end, and I didn't realize that I've done a change to that has in fact has impacted them. And there was nothing that, this was a runtime problem now. It's not a compile time. And now we're starting to lose some of the value that TypeScript could be giving to us. So let's come into our resolver, into our index.ts. And let's delete that one out of the resolvers, save, and, no, I did have a file system watcher running. Okay, that should restart, and no errors this time. Come back to our query, we'll just reload the server, reload the connection to our server, and we can see now under the documentation, we have game, which returns us our game object, which has players and so on and so forth. And we can, so we could go games, we could go to players, we could go games, we could go players, we could go games, we could go players, we could go games, we could then add, let's just add the ID. All right, so this is a perfectly valid GraphQL query, and you can see where you're maybe starting to get some problems from like a DOS vector for your own server. We're not going to execute that because, well, I do kind of need this laptop for at least the next 30 minutes. So let's stop that. And let's look at how we can maybe tackle some of these type-safe problems that we're starting to see come into this. So jump over to my next VS Code. Oh, actually, no. I'll jump forward one more than this because I'm aware of where we're at with time. And like I said, I'm the only thing standing between everyone and having a drink at the end of the day. All right, so we've jumped forwarded about 3 steps, so we're up to step 5 in my workshop sample here. And I've gone ahead and done an implementation of our resolvers. So we can see that here. So this, I've also expanded the schema a little bit, but this is now where our resolvers are starting to look, what our resolvers are starting to look like. If we compare that to our schema, and let's just move the schema side a little bit smaller so we can see the resolvers better. Yeah, like it really is starting to look similar. Oop, if I come down to query at the bottom, we have games at the bottom where we're getting game by ID, we've got games, we go into this thing data source, and if I start hovering over, we'll see that, well, it's any's all the way down. And look, that's a perfectly valid way to write TypeScript. It's like, I can't be bothered actually, like, I'm going to use TypeScript because I've said I'm going to use TypeScript, but we're just going to type everything as any and it's fine. The compiler still runs, it still all passes, but we've just said that, ignore any's is a TypeScript linting rule and it's going to be fine, right? No, we've lost all this value. I might have, like, I'm accessing data sources.game. Like, is that how I access my connection to my database backend for downloading games? I don't know. I don't have anything that's helping me. I've completely lost the value that TypeScript can bring. Similarly down here, like I've got this player answers that have come back from working with a game, and I'm having to map over to that. Did I get that correct? I don't know because it's not there. So how do we address this? Well, again, we can, I've pre-installed an NPM package. It is called GraphQL Code Gen. So this is another open source tool. GraphQL Code Gen, I've installed the CLI already. And if we give this an execute, npx GraphQL Code Gen, let's close that one because I don't need that open anymore. We'll have a bit more space, pop the screen taller. All right, so what kind of application are we building? Well, we're building a backend API. Where is our GraphQL schema? It is at //GraphQL/schema.graphql. So it wants to find, where's an external file that I can find a GraphQL schema that I can load a type system from? What do I want to generate? I want to generate some TypeScript type definitions, and I want to generate some TypeScript resolver definitions. Excellent. Sounds like a good starting point. Where do I want it to go? Let's go to so we're going to the wrong/GraphQL/generated.ts. We'll generate an introspection file. That's just a file that your server can provide to other clients that want to understand the schema that's being exposed for GraphQL. We'll generate a YAML file for the config, and we're going to add an npm script so I can run the code generator to generate these again in the future. This is going to install a bunch of plugins, so it's going to add a bunch of plugins to my package.json to do the things that I've asked GraphQL Code Gen to do, generate my TypeScript types, generate TypeScript resolvers. And I'd forgotten to pre-install those ones, so npm is going to take a moment or two to download that over the Wi-Fi. It's not too fast. These packages are actually pretty small, thankfully. So we'll give that a second. But this GraphQL Code Gen is capable of generating a whole bunch of different language files from a GraphQL schema file. If you're working with .NET, it can generate you .NET models. If you're wanting to work client-side, it can generate you stuff for React or Angular and Vue and Svelte and stuff like that to integrate directly with. It can generate, I think it can also do like Java and maybe 1 or 2 other programming languages. But it's also extensible. You can write your own plugins so that you could generate code in the format that's going to be right for the kind of application you're building and the problems that you need to solve. All right, so that's done. Let's go npm run gen. So we'll generate our TypeScript information from our GraphQL file, our GraphQL schema. There we go. It's parsed, generated outputs, and let's just move our schema away. We'll go to generated, and here we go. We have this is what it's generated for us, and if you've worked with TypeScript, you're probably seeing some of the things that it's doing. Like at the very top, it's generating a maybe type. So this is how we could represent an optional thing in our GraphQL schema. But predominantly our things are non-nullable, but things that are nullable, well, it could be a maybe of t. T being the thing that we could return, or null, because that's what we've said. We've got other ones to like pick out fields if we're doing for the way that we're working with queries, but then it's defining the Scala types that are available. You'll see that ID is being treated as a string within inside of TypeScript because that's what the GraphQL server will serialize it as. We also have our game type that's there. The game state, the enum that we've generated, it's actually generated that as an enum in TypeScript we can use within inside of our code. I don't have to write that myself. And if I go back and add another field to my enum in the schema, that's going to be available within inside of TypeScript. What really becomes powerful is when I get down towards the bottom and we have our resolvers that have been generated. So for accessing a game or the games or anything else that's there, we have TypeScript definitions for that. So remember back here, we've got this and we have a bunch of underscores because it doesn't know like what are parameters taking to this and that kind of stuff. Well, if we strongly type this, resolvers, import that from generated, a lot of our squigglies have gone away. We now know that game is going to be returning, like this is the arguments for game. It's expecting to return a game type. We can see that the ID parameter that we're passing to get an individual game exists. It's a string because that's what we define with inside of our GraphQL schema. We're now getting that type system in GraphQL brought across into our actual code base. But we've still got some squigglies around and like we still don't know what our data source is. Like it's still in any, like am I correctly talking to my databases to get back the data and that kind of stuff. So how do we address that? Jump forward to yet another example, yet another step that I've got in here to our API folder. And I did install my node modules, excellent. So this, someone's got a phone call coming in. Who didn't turn, I didn't put the, here, like at the cinema, make sure you turn off your phone and everything before you enter the room. All right, so we need to somehow know what our data access is going to be. We can see that I'm importing that up here. It's an in-memory data source. We can see that strongly typed as data sources of Apollo context. If I come through to here and to the Apollo context, I've got there's some type safety within inside of this. So Apollo context is the third argument that gets provided to a resolver, a function that's going to execute when your query is processing things. And on that, you can put a whole bunch of things like to do, I guess, like a .NET analogy for anyone that's maybe more familiar with .NET. This is like a way you could do dependency injection. So this is like every single time the server receives a request, it will create an instance of the Apollo context. It will then, in this case, it will just add data sources because that's all I've defined there. But you could be, say, hydrating a user profile out of a JWT that's attached to the inbound request. It could be loading some additional data from your backend systems that's needed for every request to do like access control or validation or anything like that. These are things that you just want, like you want available to a resolver, but you don't. But they're to be generated at runtime based off of runtime information when a request comes in. I only have data sources here, strongly typed. We have a bunch of interfaces representing the data sources. As in this example, it's both got in-memory and a Cosmos DB backend. But yeah, I want to know that it is game and stuff like that. So how do we get that information over to our resolvers? Because that's coming in here. And it's obviously erroring because it's just an any type. Well, for that, we can use GraphQL CodeGen. So this is the GraphQL CodeGen file, config file that was generated for us when I ran through that wizard. And I can configure this to give it some information about the type system in my application, so to give it some help. So I'm going to say in the config for this one, And let's see if I mess up white space indentations, config. We're going to say the context is a type at, whoops, I wonder if I need quotes. I never know if I need quotes. We'll put them in there just in case. So that is inside of GraphQL. Actually, no. It will be inside of the Apollo context TypeScript file, which is here. And then we have to specify an export from that. Exported as Apollo context. Now let's do npm run gen to generate our code. We'll see if I got this right. I did not get that right. Awesome. What has it been unhappy about this time? It has errored because I'm missing a whole bunch of node modules, I think. Can't find module WS. Okay. npm install. Because I was sure I'd done that beforehand. Okay. Let's try running generate again. Run gen. Let's see. Awesome. 2 failures in a row. Exactly the same error message, which means that we're just going to go to the code that I prepared earlier. Let's go open a new folder. We'll go to this one here. One that I didn't pre-cache, which means I'm going to have to run npm install again. Awesome. So I'm actually, if you do want to have a play around with this example workshop as well, I have VS Code dev container definitions set up for every step along the way. So that will set up the correct version of Node for you. It will install some VS Code plugins for you that are going to make it easy to work with GraphQL and all that kind of stuff. I talked more about dev containers in the VS Code talk yesterday, but this just makes it so much easier to, you don't have to worry about pre-installing a heap of stuff. If you want to have a play around with this, you pull it down, it will grab the right Docker images for you and set that environment up, and then you can delete it at the end of the day, and it's all gone, and you don't have to worry about uninstalling software after the fact. Well, I mean, you'd have to uninstall Docker if you didn't have that previously there. All right, so now that's ready, we can come into API, and we'll do npm install. Hope this installs everything correctly, and we will come to the code gen.config file. It's thinking, there we go. It's really thinking. Oh, I'm taxing my machine a little too much. Come on, I know it's end of day, but you can do it. We'll get there. Or we might be getting to the bar the first, because my laptop might be struggling a little bit more than I would like it to be. All right. We'll give this, oh, no, there we go. That file has opened in the background. Excellent. Okay, so, it was context type. Maybe that was the error that I had. It was context type, not context. But anyway, we're specifying where the Apollo context is. We're also specifying some mappers for our backend data types to GraphQL. Because maybe the data structures that we've got within inside of our database don't map exactly to our schema that we're exposing to a client, which kind of makes sense. Like, you don't necessarily want your database in its rawest form available for anyone to query. That could leak out maybe some business logic around the way that you structure database in your backend, or maybe the data structures in your backend are not optimized for the way that you want clients to work with it. So you want to do some translation layers. In this application, for example, we actually have a bunch of additional fields on some of the types that we don't want to expose to the clients. At least they're not relevant for the game that we're building, at least at this point in time. So we need to deal with that in a manner. So that's what we're doing, and this is taking an extra minute to install stuff because I don't think I have the generated file. No, I don't. But let's go back to resolvers. So we can see what will happen. We will get a bunch of, we will get a red squiggly because the generated file doesn't exist yet. Data sources is going to be undefined until we do that. But give it a second. The terminal, come on, taxing the conference Wi-Fi. dancing. Any questions while I'm trying to fill time? No, if anyone does have any questions for the rest of the talk or anything like that, please do just put your hand up. I'm more than happy to field questions along the way rather than just waiting to the end. If there's something that you want me to look at again or like revisit or tackle contextually, do please shout them out or at least pop your hand up so I see you, and then yeah, we can do that, and it helps me fill time while I'm waiting for node packages to install. Yes?
So you've shown sort of code generation from the schema definition to TypeScript.
Yes.
Is there anything that does the opposite in case you want to kind of do more of a code first?
Yes, so that's actually a really good question. So the question for those that couldn't hear it, maybe down the back and for the recording, the question was, we've done generation from schema to TypeScript, but what if you wanted to go the other way around? Maybe you prefer a code first generation model rather than a schema first. Yes, there is a TypeScript project called Typed GraphQL. I think it's Typed GraphQL. I have a link to it in the slides that I'll bring back up after this. And what that does is it uses TypeScript decorators to annotate classes in your TypeScript application as this is an object type that I want to involve. This is the query type. This is a resolver. These are the fields, and this resolver maps through to this TypeScript type definition or this TypeScript class. So yes, you can do that. With .NET projects like Hot Chocolate, they have a similar thing. They can be schema first and generate, you can take a schema and then merge that with .NET classes, or you can do .NET classes and use attributes to annotate that to expose as GraphQL. So yeah, actually really good question, because yes, I'm showing one approach, and I know that that might not be the right approach for everyone else. Everyone that wants to go, code first does have its place. And yes, you can definitely do that with TypeScript and obviously with more strongly typed and structurally typed languages. Awesome. So I'm still getting errors. That is great. We're going to go up one level and just do an npm install up here to see if maybe there's a package at the root level that is just a transient dependency that I haven't got there. But that is very frustrating that I'm continuously having demo fails. Otherwise, I'm going to have to bail out to the very completed version of the workshop, because that's the final fallback plan. I do have everything done, tested. I tested it like 2 hours ago, and it should still be working. If it doesn't, I'm just going to fall down, cry in a heap, and let everyone wander off for the rest of the day. Actually, while that's installing, let's go and just have a look at this code first approach. So. Yeah, typed GraphQL, if I get to it. So that's typed GraphQL. If you want to, I like putting QR codes in because I find it's you can quickly scan that before trying to write down a URL that a presenter has put up there, particularly when I was doing virtual talks. But yes, typegraphql.com, we'll find that. Actually, let's copy and paste it, have a look, because that can help pad out runtimes. Yeah, but it has quite a nice syntax for working with this kind of stuff. So that's the difference. So this is a type first approach. Sorry, let me zoom. Got that. There we go. So we've defined it as an object type. So this is similar to type. The type syntax that I had in the schema, annotating what things are fields. We can see that one of those fields is going to be non-nullable, the title. The field description is going to be nullable. And we can see that they've got a computed field value, which is the average rating there. But what does that expose? Because we don't get that information as easily from a computed property inside of TypeScript. So yeah, that's an option if you prefer a model that way. Okay. Last attempt at this npm run gen. Come on, everyone. Fingers crossed. It's got, I think, a little bit. Yay! Finally, it works. I obviously have a dependency. So I have two package JSONs in this project. Obviously, I have a dependency in the top level that I didn't realize is a transient dependency in the downstream levels. Okay. So that's now generated, and now, because we've specified a context type that's inside of my application, a type that I've defined, there's some information around the way my system is built, we can see that data sources, now knows what it is. So we now know that we have an iGame data source here. I know that there's a method called getGames, and that is going to return me a promise of game model array, because I'm expected to return a list of things from here. Resolvers in Apollo can be synchronous or asynchronous, so you can return a promise or you can just return the direct type. So obviously in this case, we're returning a promise array. If I come down a little bit further, because we've got some data back, we now know that, say, player answers has a type. So I can perform that map operation correctly and generate out all the sorts of types that I need there. But I mentioned that maybe the data model that you've got within inside of your database doesn't necessarily match the types that you're wanting to expose out in your schema. So if we come back to our schema, we'll see that the question has ID, question, a camel case, correct answers, and an answers field. But if we come to the sample data structures that we're working with, we'll see it looks a little bit different. There's a bunch of additional fields, category, type, difficulty, and we'll see that there is correct answer, but it's got an underscore in it. It's snake case, not camel cased. We also don't have an answers field. We have incorrect answers and correct answer. So this could be a problem because, well, it doesn't know how to resolve, like, how do you resolve those two types between each other? It would actually result in a runtime error. And I'm going to very quickly delete a bit of code. You did not see me write this code already. It's not there. Save that. We'll do npm start, and we'll see what happens by that lack of understanding between the two different type models, our database and our client. If I had have had the other one working, we would have you wouldn't have had to see me quickly delete the code. But all's well that ends well, I say, before my server even starts up. All right, code generator is done. Server is starting. There we go. Open that in a new browser window. Here we go. Yet another port. I'm getting a lot of random ports this time. Because I'm running in a dev container, it has to do port forwarding from the Docker environment. And generally it forwards on like the same port, but it should be 707 something, but this is getting me something in the 5,000s range. Okay, but anyway, I'm digressing. Okay, here we go, Apollo server. If we were to get back some data and we've got an error. Fantastic. Really, I really feel like this is just punishment for being the very last talk today. Okay, let's just go on to a fully completed working version of our application. If I can kill that server. Stop it. There we go. All right, we're going to jump over to here. So this is a fully implemented version of that, that workshop. That it isn't even working. Just I feel like this is just end of day. We're done. It's lost connections with Docker. Yeah. All right. We'll give it one restart because, well, we've only got about 10 minutes left. If this is unsuccessful, I'm going to apologize because I haven't been able to run through the demos that I was hoping to get through. You can go check out the GitHub repo, which has the completed workshop up there as well. But it looks like I might have pressed my luck a little bit too far by running, I think I've got 7 Docker images, Docker containers running all on my machine at this exact same time. And we can see how long this is taking. So, yeah, yes, yeah. Save me with a question. No, it's opened. Hold your question. No, you can ask away. Thank you for attempting to rescue me there. It is much appreciated. So actually, we are going to just do debug start run. Okay, so this version of the application actually has a fully implemented front end as well. And we'll have a quick look at the front end code because, well, it's written in React with TypeScript. And, well, I probably want that type system available to me in the front end as well, don't I? Well, because I want to know what that contract is. I want to know that if I'm working with that GraphQL schema, what are the queries I can perform? What are the types that I get back and all that kind of stuff? So that's going to start up. And while that server is running in the background, and I think it's just erroring out in a bunch of ways, but we'll see. So what I've done in the in the client is we go to github.com and we just look at it at GitHub. So you'll find this at GraphQL TypeScript workshop. This is so this is the workshop that you'll find. Actually, I'm going to show you. Use github.dev, press dot on any repository, and it opens it up in a stripped down version of VS Code running entirely within inside of the browser. I can't actually launch the application from here, but I can navigate around the code base. And it's still going to bring my theme across. Isn't that fun? I thought I'd bring some color to the end of the day with this 1984, so cyberpunky theme. That's a link to a YouTube video that I gave at TSConf of this workshop. It's about 2.5, 3 hours long, where we go through each step of the way and build it a lot more successfully than I have done in the last 55 minutes. Anyway, so inside of the front-end application, I've got this operations folder, and these are the queries that I want to perform, or the mutations I might want to perform against my backend. So let's say we want to have this one here where we're going to get back an individual game. So we're getting back a game by its ID. We're using the $ syntax to pass in the ID as a variable to this query. And it's then going to give me a game with some questions and the questions of the game and the answers. I'm then using GraphQL CodeGen to generate out some TypeScript type definitions that we can see up here. We have getGameDocument, which is that GraphQL query embedded. It's also strongly typed. So we would see this, I'm not going to get the type information in the browser, but it would know that these types are available. It would know the fields that you've selected. If you were to add more fields to the operation, so the query that you're performing, they'll be available with inside of TypeScript, and we can say loop over them, do whatever we need to do, send it up as a mutation, and that kind of stuff. But I think I've pressed my luck enough for today. I am having cascading demo files left, right, and center. That one looks like it might be kind of up and running. Actually, it does look like it's up and running. We'll have one final press my luck. If this does work, I hope I get a round of applause for persisting. Here we go. It should be at localhost. It should be at it should be at localhost, because that's how the port forwarding works. Come on. Really hope this works. Although I'll probably fail the trivia if it does work. It's just got a sample set of tech trivia questions that I pulled from an online resource called OpenTriviaDB. Okay. I'm gonna call that there because that is definitely me pressing my luck too far. Things are not happy. Okay, so let's come back to my slides. Even PowerPoint has given up on me for today. Thanks for coming now. Where's my screen gone? Oh dear. Okay, on my laptop screen, PowerPoint is just it's black. There's nothing that it's doing. I don't know what slide. I can't see what slide's next. Oh no, there we go. We've failed at coding time, but if you do want to have a play around with this workshop or check out the longer form video that walks through how to build this application from scratch, you'll find that at github.com/AaronPowell/GraphQL TypeScript workshop. I'll pop this link in the Slack channel. GraphQL Code Generator is what I was using to generate those types. You'll find that at graphqlcodegenerator.com. Everything here was built on open source technology, well, except for Azure Functions. If you deploy that in the cloud, that's not open source. Parts of it are, but not the entire thing, not Azure. That's not open source. And if you want to learn a bit more about GraphQL, particularly GraphQL with Azure, I've got a blog series. I think it's up to 8 or 9 parts so far that covers off getting started to like hosting options with inside of Azure, how you integrate with logging platforms, how you do real-time with subscriptions over WebSockets with inside of Azure. And I've got a few more articles that are in the pipeline for that. I also cover off security as well, because that was something that is a tricky story with inside of Azure. So how do you do authentication and authorization in a GraphQL at a server level? Authentication is something that that is different from that. But thank you for persisting with me for what has been one of the more challenging demo-heavy talks that I've given in recent times. I hope that there was at least some stuff that was useful enough other than me just like cursing at my computer. If you want to, I will try and get these demos up and running on my laptop. And if anyone wants to find me and see them running, to see like actual proof that I can make this work, find me afterwards. But yeah, I hope you enjoyed, and I hope you enjoy the rest of NDC Melbourne. Thanks.